So today I'll give an introduction to electrical power generation. So you might be wondering what is there in the subject. It is like mechanical energy is converted to electrical energy. So let me make it more interesting. So in your power system, basically the power is generated, transmitted and distributed, and even it is utilized. So nowadays what we are trying to do, we are trying to improve the performance of the grid. So there is something called smart grid and its technologies. So we are trying to monitor the generation, transmission, distribution, and utilization. So why we are monitoring? So that we can improve the performance throughout the system. So at the distribution side, there is technologies like distributed generation, demand side management, demand response. So what do you mean by distributed generation? By distributed generation, the power is generated at the distribution side and it is injected to the grid. So by how is it possible? The government has introduced deregulation. So what do you mean by deregulation? The power is actually you can generate power. The private players can generate power and inject to the grid so that they can generate some revenue. So you might have heard about rooftop solar installations. So even the residential consumers or commercial consumers can generate power. They can utilize it in their own premises as well as they can inject the power into the grid. So how you will measure those? You have to install smart meters at the distribution side. So there is a huge research happening in the area of demand side management. So we have to manage the power sources as well as load, and there is something called demand response, and there is distributed generation. So we will see that in the upcoming classes. So let me share the slide so that we can have a better understanding on various power generations technologies in this subject. Okay. So we are going to today we are going to discuss on structure of power system, generation, transmission, distribution, power loss minimization, basic components of thermal generation. So the power is generated, transmitted, distributed. So we have to monitor this even in the utilization side. Utilization side. So that is going to be utilization also. So basically the power generation, we can classify it as conventional sources as well as non-conventional sources. So mostly the thermal energy sources such as coal, natural gas, nuclear fuel, oil, all these are coming under conventional sources. Whereas we have non-conventional sources such as wind, solar, tidal, geothermal, biogas. So the problem is because we are depending on thermal sources, there is a huge carbon dioxide emission. So we are trying to minimize the emission by compensating that with the help of non-fossil fuel based sources such as wind and solar. So basically how the power is generated, mechanical energy is converted to electrical energy. So what is the machine used here? So there is something called a generator. We call it as a alternator. The technical term is alternator, or it is also called a synchronous generator. Why is it called synchronous generator? Because it is rotating at synchronous speed. Then only we will get a fixed frequency. So in your machines, you might have studied about the construction of synchronous machines, such as salient pole, non-salient pole, and you might have discussed about the speed of operation, all those aspects. So can anyone tell what is the voltage level of generation in our country? So basically it is like 11 kilovolt. So it's in the range of 11 to 35 kilovolt. So another aspect is in your when you go outside and you have seen a transmission line, you might have observed that it is written 400 kilovolt. Why is it written like that? So we will see that how the power generated at 11 kilovolt is stepped up to higher voltage. So what is the reason behind stepping up the voltage? So this illustration here gives the various power generation levels in our country taken from this particular citation. So as we discussed, thermal power generation is 70% of the power is generated from thermal energy sources, whereas hydro and renewable, these are all non-conventional sources. So it comes around to 30% approximately. So we have nuclear power generation. So nuclear power generation is most energy density power generation happening, but the problem is we are in shortage of fuel. But even though we are in shortage of fuel, we will discuss about its generation in the upcoming classes. Hydro generation is huge generation, but is limited. We cannot. It's very difficult to improve on the generation of hydro generation. But renewable, we can improve the installation by installing more capacity. So, but there is a huge requirement of fund in the renewable generations such as wind and solar power generation. So if you see the structure of power system, there is alternator here. So usually it is 11 kilovolt power generation. So the power we have to step up the voltage 11 kilovolt into 400 kilovolt called transmission. Then we have to step down. It's called the secondary transmission. Okay. So we are stepping down 400 kV to 33 kV, and we can give it to big industries. Uh, we will discuss that why we are actually distributing the 33 kV. And again, if the power is stepped down to 33 kV to 11 kV, we will distribute it to medium industries. And similarly, we will step down to 6 kV and we will distribute it to small industries. So finally, it is coming to residential consumers, also called domestic consumers. So we are stepping down 6 kV to 415 or 400 volt, three-phase four-wire supply here. So we have three phases R, Y, B, and neutral. So why we are actually following this pattern of stepping up and stepping down? Because we will see with the help of a numerical example. So the power, what is the equation for power? Power is a multiplication of voltage and current and power factor. So if you take the current, power and the equation becomes P by V into PF. P is the power, V is the voltage, PF is the power factor. So let us assume we want to transmit a power of 100 megawatt with 10 kilovolt and unity power factor. So what will be your current? So if you substitute this 100 megawatt according to this equation, and you are taking unity power factor, so we don't have to, so that is 1. So we will directly substitute the voltage. So what is the current? Is 10 kilo ampere. Let us take the same scenario of 100 megawatt transmitting with the help of 1000 kilovolt at the unity power factor. So your current become 100 amperes. Now we have another formula. Power loss is given by I square R. So whatever current, we have to take the square of that multiplied by the resistance. So let us assume you have a resistance of 10 ohm. So what will be your power loss? It is like 1000 megawatt. But in this case, when you substitute the current of 100 ampere, and we will get the power loss of 100 kilowatts only. So this 100 megawatt is far greater than 100 kilowatt. So this is the reason we are actually stepping up the voltage. This is, of course, it's an arbitrary value just to explain the concept. So we are actually possible to step up the voltage from 11 kV to 400 kV in the previous transmission. That is basically to minimize the power losses. So we have less power losses comparing to this case where you are trying to transmit it with the lower voltages. So this is the main reason we are stepping up the voltage. So we have like 11 kV transmission, 11 kV generation, 400 kV transmission. This is done because we have to reduce the power losses, and there is a distribution. So we have different voltage levels. It is important you have to note down these voltage levels, because these are all standard voltage levels we are following. So this is step down with the help of distribution step down transformers. So we will see the power generations. Basically, we will see thermal generation, hydro generation, nuclear generation, wind and solar. So thermal, hydro, nuclear, all these are conventional source of power generation, whereas wind and solar is non-conventional source of power generation. So today's class we are discussing till the thermal generation. So basically the thermal energy source is coal, and we are actually giving the coal to the boiler because we have to burn the coal and we have to generate steam. So steam is actually high pressure steam, superheated steam. It will rotate the turbine. The turbine shaft is connected to the alternator, and the steam out is condenser, and it is fed to the boiler in the return path. So what is happening? Chemical energy in the coal is converted to heat energy in the steam. Then it is converted to mechanical energy and electrical energy. So in this electrical energy here, you are getting three-phase AC supply. So this is basically, it's going to be 11 kilovolt supply. So this is the basic components in a thermal generating unit. So we will see the remaining in the next class.